Hello and welcome. I'm William McKnight, the president of McKnight Consulting Group, and I'm here with Ashish Yajnik, the vice president of Vantage Cloud at Teradata. And we are presenting to you the 5 best practices for migrating large analytic systems to AWS. So, Ashish, how are large analytic systems different than other systems?
Well, thank you for having me here, Willem. And what I really wanted to talk about are the different segments of the data warehousing use cases and workloads. Today, we have, if you really segment it down to the types of queries that you're trying to run, there's a basic set of data warehousing or data mart capabilities that customers need. And then there's more enterprise grade capabilities as you scale up your environment. And so, Willem, these are the types of capabilities typically our customers look for. On the basic data warehouse side, clearly agility, simplicity, elasticity, pay as you go, those types of elements and attributes are much more important for a basic data warehouse. Whereas for our large enterprise analytics customers, in addition to the simplicity and ease of use and elasticity, they focus on linear scalability, high concurrency, the complexity of workloads and SLAs are way more important, and that's where Teradata sort of plays in both the segments of the market. We have an offer for a basic data warehouse with a lower price point and an enterprise analytics platform for some of our larger customers.
And what is that above and beyond the basic data warehouse?
I think if we look at the types of things that customers are trying to do here, William, we believe in this whole multi-dimensional scalability across these 3 different or 8 different vectors in our customers' environments. And I'll build this thing out so that we get a clear view on what those 8 dimensions are. When we look at the 8 dimensions, one of the most interesting things is sort of the data volume. The amount of data that sits inside an Amazon's EBS or an Amazon's S3, leveraging that, joining that data in real time is extremely important for customers.
So does everybody need all of these, all 8, when they get to large analytic systems?
What we've observed, William, is that the environment is fairly complex. You've got millions of concurrency happening every month of queries. You've got a schema that requires a 5-way or sometimes 10 or 15-way complex joins. You've got latencies and response times that are continuing to increase up for these customers as SLAs increase. And so effectively, it's a factor of 5 to 8 of these vectors that typically play in a customer's environment. And and that's where the Teradata's core value proposition or IP is so critical in ensuring that all these 8 vectors are nicely balanced in a customer's environment.
Yeah, so often when people refer to scalability, they really mean data volume. But you're right, there's all these other dimensions of scalability. It's hard to know that you are going to be meeting all of them with your platform selection unless you actually test them.
Absolutely, William. I think we recently had a situation in a customer's environment, and on the right hand side, you'll see a customer case study where a leading restaurant operator was trying to modernize their stack as they migrated from on-prem to cloud. They had a fairly complex environment, large number of concurrency, large query sets. They had mixed workloads where they had a lot of millions of tactical queries hitting the system, as well as a lot of ETL jobs happening on that system as well. They had million plus guests every day, and their data sets coming back into Teradata. And they've been doing this for 10 years in an on-prem world. So as they migrated to cloud, they wanted to make sure that the complexity of their queries, the schema, the joins, the latency and throughput are really balanced for all their workloads that they run today. And William, that's the core IP that Teradata brings to the table, which is this advanced workload management. We know that customers run multiple of these workloads on a system, very high end. Some of them are mission critical, have a large need for IO compute and memory. Others are tactical, very high amount of large number of sort of files, very small IOs. And so prioritizing IO, CPU, and compute using metadata analytics and autonomous sort of capabilities helps Teradata minimize the churn between these different applications. And there's not a noisy neighbor problem, because the way the Teradata architecture is structured, William, is that we have sort of a notion of an AMP. An AMP is a unit of parallelism, and there are thousands of these AMPs running in an environment to help us in a good way saturate the resources and to minimize the response times. So that query optimizer, the workload management capabilities of Teradata helps this particular customer deliver to the 8 dimensions of scalability that we just talked about.
Okay. Well, I'm glad you're keeping the focus on business objectives, because that's still the way to make these platforming decisions successful for the company. Now, Ashish, do you have something to show us?
Yeah, I thought that we'll run through a scenario of what do users actually go through when they install and deploy Teradata. Teradata has built a lot of seamless onboarding capabilities where you can get the systems up and running fairly quickly. And once you get access to the system, it's run as a service. So you get a self-service console. So I thought maybe in the demo one, I'll quickly talk about what type of capabilities are we building in that particular console. So when you log into the console, it's a self-service UI based on the different personas. So right at the top, you'll see an editor button for our very SQL savvy personas. In the middle, you'll see an analyst view, which gives visualization and workflows for business analysts. And lastly, the console for operations. And this allows us to ops to scale the system, do reporting, chargeback, showback, and metering type of capabilities. So let's go and look at this console, William, and I'll walk you through some of the capabilities that we've built. Now, when you log in, you'll see if you have 5 or 6 or 7 or 10 different instances, this is the central place you'll see a visual of all those at a high level. Let's click down on one of those and see what that particular instance looks like when you click on that. So when you click on the View Site button, it takes you to a landing page where you can create your own custom dashboards. We call them cards. And these cards describe the instance of what is inside the instance. For example, it's operational, it's capacity, it's running on AWS, it's in US West 2, the capacity of the storage associated with that, number of nodes. And then if you scroll down, you'll get to see some of the backup and DR capabilities. So how many backups were taken, what's the RTO, RPO. We use EBS volumes or EBS snapshots for backups. You also get to see your contract and your consumption hours. And if you want to load more data into an S3 bucket for Teradata to access, we have a load utility right there as a self-service utility, essentially. And there are some instances around memory and T-codes and sizing that Teradata typically provides you in the self-service console. Now, there's an active management capability as part of that. If you want to change, let's say your CPU utilization has reached 90%, and you want to scale out by adding more nodes into the cluster, independent of storage, by the way, with little to no downtime. And if you want to add more storage, independent of the compute, you can do that using these capabilities. And then finally, you get to see chargeback, showback, metering reports on the Vantage units that you consume by the department, so you can charge back and show back to the end user. So that sort of is a capability that we built just for the operators. Now here's an interesting capability that we've recently launched, William, which talks about connecting to and querying Amazon S3. It's very important for customers to place their cheap and deep, high volume data on an Amazon S3 while continue to have performance sensitive data on an Amazon EBS volumes, so that your latency and throughput are optimized and your cost SLAs are also in check. And so Teradata has launched a capability this year that allows Teradata to join a data from an Amazon S3 with a structured data that sits inside the EBS volume. So I'll quickly do a demo of that and the backdrop story around that. So the main use case that this particular customer had, well, this was an electrical vehicle manufacturer, and they were getting a ton of reports on the bad batteries. And it was costing them millions of dollars for warranties and replacements, and they couldn't pinpoint the problems out. Now, all their structured data for the battery as well as for the customers and the dealerships sits inside the Teradata Vantage in an EDW structured data sets. But their larger battery data that comes out of the factory, whether it's the voltage information, lot information, all that sits inside an Amazon S3 in a much more cost-effective storage, billions of records essentially stored there at scale. And so what we'll do right now, we'll look at what happens when you have to marry the data together. So in this particular case, when you first isolated the problem, the idea was let's go and let's do a walkthrough and look at the preliminary analysis based on the VIN numbers of the cars that reported the problems. So you write a SQL query in the editor that I just talked about. This is, by the way, a web editor that we just launched. And you narrow down the root cause and say, AutoWorks has the most defective batteries. Okay, that sort of narrows it down. But let's see if we can figure out whether the car model seems to matter or not. And clearly it does not. So let's move on from there. And then we start writing more queries to figure out, is there a particular factory that has this issue? And the Jackson plant clearly boils down to being the problem area for us. And from there on, when we double click on the Jackson plant and write more queries, the 20RD0 part number has the maximum defects. And here you'll see the visualization and that the lot 4102 within that has the maximum defects. You can see this information graphically using our user interface, or you can see it using queries. Now the interesting things will be that the detailed battery data that comes from the factory sits inside an S3. So we create a foreign table here that allows Vantage to go and access the data on an S3. And we can select from the S3 objects natively with our regular SQL essentially. And so look at this JSON file. It's not human readable at the moment. So let's shred this JSON format and get into a much more structured format for ease of readability essentially. And when you look at that, then you run your report, you'll be able to go and now that you have got column level sort of readability here, JSON items, now you can figure out which of the parts you can go and look at. And when you now let's join this particular report from the report that we generated to figure out the Jackson plant and other object and part numbers. So when we join the data from the S3 to the Teradata data that sits inside the EBS volumes, we'll be able to locate exactly on that plant what happened and why did the batteries fail. So in this particular case, we figured out that the batteries have actually failed because the measured capacity of the voltage for certain lot had just gone bad. And so 4098 lot was in spec, it had low voltage, and now we know that we'll inform the Jackson plant and go back and correct that problem. So marrying the data off from Amazon S3 with the data settings inside Amazon EBS volumes and running much more complex joins that we talked about allowed this particular customer to pinpoint and isolate the problem that their customers were facing. So that's the power of Vantage Analytics, marrying the world of structured and semi-structured data.
It's like a workbook approach to a business problem. That's not the interface that a lot of people understand about Teradata, but it's very modern, very slick. What about some other forms of AWS integration?
That's right. I think when we've been working with AWS quite extensively to figure out what services of AWS completely make sense for our customers as they modernize the platform going from on-prem to cloud. We don't want our customers to do a lift and shift of their existing infrastructure, which was built 10 years ago, into the world of cloud. So together, AWS and Teradata have been helping our joint customers figure out what cloud native services to use as they modernize their ETL, as an example. ETL has been very much a batch-oriented process where every day you load billions and millions of records into Teradata Vantage, and that's time-consuming, CPU-consuming, and by the time the data is changed, the query action is taking very longer to process. But with Amazon Kinesis integration, with the Lambda function integration, now we know when the data is essentially changed, and it's real-time ingestion of the data into Teradata Vantage. And that's just one of the many examples, William.
Yeah, this is a lot more than I would expect for initial foray into the cloud. So this is really well developed. And what I like about it is you've got real time all the way through to batch, whatever form of integration is required. And then you have data science plus analytical capabilities and basic BI capabilities, if that's what you want. And these are some of the keys to having an analytic platform that's going to work for the long haul for your customers.
Yeah, I think we've been very sort of deliberate about making sure that we use the best of breed capabilities from AWS, integrate them into the Vantage platform so that our customers can modernize their stack. A very clear example of that is the work that we've recently done with snapshots on the EBS volumes, William. The traditional backups on-prem can take days to perform offline, but in the world of cloud, leveraging snapshots to take backups and restores, first of all, it's online, and secondly, it's about 10x faster than anything that we've ever achieved in the world of on-prem. So clearly, integrating with these capabilities like Amazon EBS snapshots makes sense to modernize the architecture for our customers.
Okay. Do you have a list of all those AWS services?
Yeah, I do. Instead of going through each one of them, I will talk about some of the buckets of innovation that we have jointly built between AWS and Teradata. So we've been leveraging AWS Private Link as an example for securing the data sharing and interoperability. The key management is very important for our customers as they build enterprise-grade capabilities. They want to manage their own keys, but still want the software to be delivered as a service. So AWS KMS clearly helps them in that. IAM helps them in that bucket. I talked about data lake capabilities. We just demoed that. So deep integration with Amazon S3, 360-degree view of the business, essentially. Integration with Glue for cataloging, as well as modernizing the ETL. Integration with AWS EMR, William, is a fairly critical capability we just built, where we can do query federation between Vantage system and AWS EMR using our query grid capabilities. And soon you'll see much more capabilities around auto scaling, and doing more things with Amazon EBS snapshots, using it for DR, copy reuse, copy data management type of services that we'll be building on top of the Amazon EBS volumes, essentially.
Well, I'm glad you specifically mentioned Glue. We really like that for its crawlers, its low-code capabilities, and its streaming capabilities. So, Ashish, we've got to give them the 5 best practices now. Obviously, the platform is important. I like to say picking the right platform gives you room for error and puts the wind at your sails. But we also have some best practices around just moving your analytics into a scalable fashion inside of your enterprise on the cloud.
Yeah, William, I think first of all, last 100 customers that we've sort of migrated from on-prem to cloud, we've learned a lot of lessons through that practice. And I think largely to your point, William, the business objectives are the much more interesting to focus on rather than technicality of things. So what we've built essentially, William, is this workload analysis tool that does metadata analytics to figure out that you are running in an on-prem environment, what was your IO, CPU, compute memory, and all the different attributes that you were using, the 8 dimensions of scalability. We measure that and we score them. And then we figure out what type of sizing in the cloud on the AWS side makes sense to meet the same SLA and performance, both in a scale-out architecture as well as scale-up architecture. So we get into a little bit of a recommendation mode using that workload analysis tool that has really helped customers understand their on-prem environments, and that has really helped them give confidence that they'll move to cloud with and then still continue to keep their SLAs. So that's sort of step number 1, William. The step number 2 that we just talked about, William, I think you hit some really good points there, that the cloud native integration, whether it is for operational efficiency, for analytics, for data ingestion, it just makes sense to modernize that stack as you move from on-prem to cloud. We've got 3 to 5 different design patterns depending upon the customer's objective or whether they want to modernize ETL, leverage data lakes, leverage Hadoop in the cloud, and how do we construct that data and pipeline for the customers to maximize that modernization. So that plan and modernize phase is fairly critical, and we are helping a lot of customers do that now. 3 is just test, test, and test. I mean, the world of cloud is somewhat different than the on-prem infrastructure that was built years ago. So in many cases, you may have to scale up, other cases you have to scale out, but you'll have to perfect that environment with testing your real-life scenarios as opposed to standard benchmarks, because your workload can be very different on those 8 dimensions of scalability that we talked about this morning. And lastly, pick the right pricing model. What Teradata has recently introduced, Willem, is this usage-based pricing, pay-as-you-go model. We call it consumption pricing, essentially. It's very relevant for your small or bursty or transient or ad hoc exploratory workloads, where the workload is going to spike up and down, maybe has an intermittent lifespan. And utilizing our consumption or pay-as-you-grow capability completely makes sense. It's really down to the TCO that customers have. But for some of the steady workloads, large-scale workloads, our capacity or subscription-based pricing makes more sense. Willem, we've also observed that the customers have a mix of both worlds. And so a blended approach might be a better approach for many of our customers who have a much more comprehensive sort of data workloads that want to utilize capacity and usage. And then lastly, leverage the migration tools that AWS has built, and then Teradata's native migration tools as well. And we're leveraging some of the CloudFormation templates and things like that. We've built a lot of rapid provisioning in the system so we can easily migrate the data and the workloads from on-prem to cloud and with no downtime at all. So these are the 5 attributes or the best practices that we really want customers to understand, learn, and adopt, and simplify and de-risk their journey as they move from Teradata on-prem to Teradata in the cloud.
Well, I like them, and I'm glad you mentioned to modernize, because while you can always lift and shift into the cloud, you don't want to miss this opportunity to get into a true data science platform, because we're going to be migrating our BI to data science here very rapidly over the next few years. And so you want to be at a platform that's going to be able to go there with you. And I also want to mention about the pricing model, that while it's not rocket science, it is something that you have to keep an eye on, even though you're moving to the cloud. So that's one of the things that you have to keep under control within your environment. You may not have to do all the back end work, but you do have to keep an eye on your pricing and making sure you're in the right model. Be ready to switch. Be sure you're in the right specification as well, in terms of the nodes that you have selected and so on in AWS. Well, Ashish, this has been 5 good practices, but are there any others that you can think of?
Yeah, I think we just want the potential folks who are moving from on-prem to cloud to understand that there are 6 attributes of modern cloud that are very important. And first of all, the cloud is a journey, and not all the workloads are going to hit on the cloud at the same time. And you have to understand and build your hybrid multi-cloud environment in such a fashion that you have hybrid data access across on-prem and cloud. You have a single pane of glass that manages your on-prem assets and cloud assets. So make sure that you understand that. The second one is the true separation of compute and storage. I think the storage is getting federated. Some of the data lakes, some of the much more deep storage sits with the data lakes. Much more efficient storage sits with Amazon EBS volumes. There is EMR, where your Hadoop environments might be sitting in. So leveraging a compute that can connect it all, independent of storage, is definitely an important consideration. The third one is integration with first-party cloud services, and we talked about those: EMR, SageMaker, EBS volumes, integration, and ingestion of modern data sources. So going from batch to streaming using Kinesis or cloud-native pipelines is essentially a very important consideration as you go from on-prem to cloud. Modernize your stack around batch to real-time, depending upon your use cases. And lastly, what we have observed, William, is that as the data scientists do a lot of data science operations and building models and scaling those models, 70% of the data that they're using sits inside an EDW. And so it makes sense, without copying the data, creating the wild, wild west. And it makes sense to bring the compute to where the data is. And so this integrated data management and scalability in the analytics is an important consideration. And lastly, dynamic resource allocation and workload management that we talked about, the 8 dimensions of scalability. And those are the 6 attributes that Teradata's cloud services have been built on. And that's why we've been able to get a lot of customers migrated from on-prem to cloud successfully.
I might add performance as well. When you can get great out of the box, predictable performance, that's one less thing that you have to worry about, because a lot of shops go into a high tuning mode to try to get decent performance. And when you're doing that across the board for all your analytics, you're not really showing off a great platform there to begin with. And you want to hit the ground running with your platform. And Vantage takes a lot of the risk off the table. And the less things that you have to worry about, the more dependable the solution is, the more you can get on with your business and actually show off the product internally by showing what it's doing for the business, which is ultimately what it's all about.
Yeah, no, that's very true, William.
So Ashish, is there anything else you'd want to add about Teradata?
William, I think we've been helping customers do a lot of migrations from on-prem to cloud, modernizing their stack. We've got a very large set of enterprise customers, retailers, global banks, healthcare companies, manufacturing firms who are taking our help in their cloud journey. And we are cloud first, and we are trying to get them to leverage their existing stack, existing SLAs, and have the similar experience from an SLA standpoint in the world of cloud. At the same time, drive greater agility, cloud native services that will help them modernize their stack. And we are very committed to helping the customers modernize their stack.
Well, thank you very much for joining today. And we have brought you the 5 best practices for migrating to the cloud. And again, they are: never forget the business objectives. Keep that in mind first and foremost. Always be hitting the business objectives as well as growing the environment to meet future business objectives. Secondly, plan and modernize. If you're not in a good data science stack today, be sure that you are sprinting to get there now, because that is the future. That is the future of our work, the future of computing. Be real and validate. Test, test, test. Ashish gave us 8 dimensions of scalability for the enterprise when it comes to analytics. Be sure that you are testing all of them as you consider which platform that you want to commit your analytics to. Pick the right pricing model. Remember, it's tricky. And finally, leverage simplified onboarding. Thank you very much. Good luck in your journey to the cloud, and have a great day.